Hi, it is JIT UA Courses, and welcome to lesson number 9 of the .NET Developer series, in which we will cover the most relevant topics to become a .NET developer. So hit the subscribe button and bell to see new videos on our channel. Okay, let's go. In this lesson, we will learn about namespaces, access modifiers, and exceptions in C#. If this sounds interesting to you, don't hesitate and hit the like button. Namespace. In previous lessons, you and I have already said that classes and other types in .NET do not just exist in a vacuum. They are inside assemblies. But assemblies are also not homogeneous inside but have special containers, namespaces. The namespace allows you to organize the program code into logical blocks. They allow you to combine and separate from the rest of the code some functionality that is connected by some general idea or that performs a certain task. It also prevents class names from getting mixed up. For example, a basic built-in library, assembly, has a namespace system, which contains several other smaller namespaces that help structure the classes it contains, according to their purpose, and connect only what is needed. For example, in the text namespace, there are classes that help in working with text. In the I/O, input-output, namespace, there are classes that can read or write files on a computer. To define a namespace, the keyword namespace is used, followed by the namespace name. For example, let's define a namespace called base in the program.cs file. Since the person class is located in the base namespace, its full name is base.person. Accordingly, using this name, we can refer to this class outside its namespace. However, the full namespace-specific class name adds redundancy to the code, especially if the namespace contains many classes that we want to use. To avoid writing the full class name, we can simply connect the namespace using the using directive. Access modifiers. All fields, methods, and other class components have access modifiers. Access modifiers allow you to set the valid scope for class components. That is, access modifiers define the context in which that field or method can be used. The following access modifiers are used in C#. Private, a closed or private component of a class or structure. A private component is only available within its own class or structure. Private protected, a class component is accessible from anywhere in its class or derived classes that are defined in the same assembly. Protected, such a class component is accessible from anywhere in its own class or in derived classes. At the same time, derived classes can be placed in other assemblies. Internal, the components of a class or structure are accessible from anywhere in the code in the same assembly, but it is not accessible to other programs and assemblies. Protected internal, combines the functionality of the two modifiers protected and internal. Such a class component is accessible from anywhere in the current assembly and from derived classes that may reside in other assemblies. Public, a publicly available component of a class or structure. Such a component is accessible from anywhere in the code. It is worth noting that these modifiers can be applied to both class components and structure components, except that structures cannot use the private protected, and protected internal modifiers because structures cannot be inherited. All classes and structures defined directly outside other types, classes and structures, can only have public or internal modifiers. We can specify the access modifier, or we cannot specify it. If no access modifier is defined for the components, then the private modifier is used for them. Classes and structures that are declared without a modifier and located outside other types have internal access by default, and nested classes and structures, like other components of classes/structures, have a private modifier. Exceptions. Sometimes errors occur during the execution of the program, which are difficult to predict, and sometimes it is completely impossible. For example, when transferring a file over the network connection may drop unexpectedly. Such situations are called exceptions. The C# language provides developers with the ability to handle such situations. C# has a try-catch finally construct for this. When using the try-catch finally block, all instructions in the try block are executed first. If no exceptions occurred in this block, then the finally block begins to execute after execution. And then the try-catch finally construct completes its work. If an exception suddenly occurs in the try block, the regular execution order stops, and the CLR starts looking for a catch block that can handle this exception. If the desired catch block is found, it is executed, and when it is finished, the finally block is executed. If the required catch block is not found, then in the event of an exception, the program terminates its execution in an emergency. It should be noted that the try block is mandatory in this design. If there is a catch block, we can omit the finally block. Conversely, if there is a finally block, we can omit the catch block and not handle the exception. However, although this construction is perfectly correct from the point of view of C# syntax, however, since the CLR will not be able to find the required catch block, the exception will not be handled and the program will crash. Catch block definition. The catch block is responsible for handling the exception, which can have the following forms. Handles any exception thrown in the try block. An example of such a block has already been demonstrated above. Handles only those exceptions that match the type specified in the parentheses after the catch statement. For example, let's process only exceptions of the divide by zero exception type. However, if exceptions of any type other than divide by zero exception occur in the try block, they will not be handled. Handles only those exceptions that match the type specified in the parentheses after the catch statement. All information about the exception is contained in a variable of this type. See the following example. In fact, this case is similar to the previous one, except that a variable is used here. In this case, the x variable, which represents the divide by zero exception type, contains information about the exception. And using the message property we can get the error message. If we don't need information about the exception, the variable can be omitted as in the previous case. Exclusion filters. Exception filters allow you to handle exceptions based on certain conditions. For their use, the catch expression is followed by the when expression, after which the condition is indicated in parentheses. In this case, the exception is processed in the catch block only if the condition in the when expression is true. See this example. Types of exceptions. Exception class. The base of all exception types is the exception type. This type defines a number of properties that can be used to retrieve information about an exception. Inner exception stores information about the exception that caused the current exception. Message stores exception message, error text. Source stores the name of the object or assembly that caused the exception. Stack trace returns a string representation of the call stack that caused the exception to occur. Target site returns the method in which the exception was thrown. However, since the exception type is the base type for all exceptions, the catch with exception type variable statement will handle all exceptions that may occur. But there are also more specialized exception types that are designed to handle certain kinds of exceptions. I will mention only a few. Divide by zero exception represents the exception generated when dividing by zero. Argument out of range exception, generated if the argument value is outside the range of valid values. Argument exception, generated if an invalid value is passed to the method for the parameter. Index out of range exception, generated if the index of an array or collection element is outside the range of valid values. Invalid cast exception, generated when an attempt is made to make invalid type conversions. Null reference exception, generated when attempting to access an object that is null, i.e. essentially undefined. If we are unsatisfied with the built-in exception types, we can create our own types. The base class for all exceptions is the exception class. According to the creation of our types, we can inherit from this class. If necessary, we can delineate the handling of different types of exceptions by including additional catch blocks. In this case, an invalid cast exception is generated in the try block, but there is no corresponding catch block to handle this exception. Therefore, the program will crash. We can also define our own catch block for invalid cast exception, but the point is that theoretically different types of exceptions can be generated in the code. It makes no sense to define catch blocks for all exceptions if the exception handling is of the same type. Here we can define a catch block for the base exception type. In this case, the catch block will handle all exceptions except divide by zero exception and index out of range exception. At the same time, catch blocks for more general, more basic exceptions should be placed at the end, after catch blocks for more specific specialized types. Because the CLR selects the first catch block that matches the type of the thrown exception to handle the exception. Therefore, in this case, divide by zero exception and index out of range exception are handled first, and only then exception, since divide by zero exception and index out of range exception inherit from the exception class. Exception generation and the throw statement. Usually, the system itself generates exceptions in certain situations, for example, when dividing a number by zero. But C# also allows you to manually throw exceptions using the throw statement. That is, with the help of this operator, we can create an exception and call it during execution. For example, our program is entering a username, and we want to throw an exception if the username is less than 2 characters long. After the throw operator, an exception object is specified, through the constructor of which we can pass an error message. Naturally, instead of the exception type, we can use an object of any other exception type. Then, in the catch block, the exception we generated will be handled. Similarly, we can throw exceptions anywhere in the program. But there is also another form of using the throw operator when no exception object is specified after this operator. In this form, the throw operator can be used only in the catch block. In this case, when entering a name with a length of less than 2 characters, an exception will occur, which will be handled by the internal catch block. However, since this block uses the throw statement, the exception will be passed on to the outer catch block, which will catch the same exception and output the same message to the console. This is all for this lesson. Thanks for watching. Hope you enjoyed it. Don't forget to subscribe to the channel and hit the bell so as not to miss the following videos in the series. Feel free to leave a comment and like this video. You are also welcome to leave any questions in the comments section. I will be happy to answer them. And also I encourage you to help brave people in Ukraine to defend themselves in this horrible war. Please use the QR code or links in the description to visit charitable foundations that help Ukraine. Thanks. See you in the next videos.